Okay, so good evening, everyone. Welcome to this third lecture. So actually, I did change the link to the lecture. So if some of your friends are not able to or don't have access to this link, Zoom link, uh, maybe they'll contact you or me. So be on the lookout for that. Okay, so I'm going to quickly talk about a logistical thing, which is about setting up project groups. So try to coordinate with Teng Teng and fill up her doc that she shared on Slack to finish up groups if you've not done so, because it's already the third lecture and we only have, I think, about another month for you to finish up a project. So read the instructions, have your groups ready, and if you want project ideas, there are some questions that I have posted for each lecture on the website. I'm going to show it pretty soon, so you can build on top of it if you want. Okay, so that and yeah. So what I'm going to do today is to revisit Lambda functions on AWS, and then the central part of today's objective is to understand containers, in particular using Docker. And so we'll try to spend time on that. And then I'll try to use a Docker container and push it to Amazon EC2, and then use the same container and push it to what is called Amazon Elastic Container Service. Okay, so a lot of words here, but what we are trying to do is, in the first lecture, we did our own DevOps essentially, because we started a server. We tried to secure it with, let's say, a firewall. We updated it using, for example, if it is an Ubuntu machine, we would do apt, get update and so on. And then we did basically our own DevOps, and then we ran our Flask server, right? Flask app, which would serve model predictions. So that's what we did in the first lecture, our own DevOps. But in the second lecture, we went in the second lecture, we went all the way to the other extreme and tried to use the serverless functionalities of cloud providers, in particular Google Cloud and AWS. So we spent quite a bit of time on Cloud Functions by Google Cloud. And towards the end, I think we very quickly saw an example of like a Hello World example on for Lambda functions, right? So we'll try to do Lambda functions a little bit more today. And between those two extremes in the first two lectures, today's lecture is about being somewhere in between, where we will, we will use some interesting technology called containers. But at the same time, there will be some DevOps work needed to get a model, deployed for predictions. But at the same time, it's not going to be it's still going to give you some benefits, which we will discuss. So benefits such as fault tolerance or portability and various characteristics, and we're going to talk about it. Okay, so just think of the first three lectures as spanning the spectrum from where you have to do everything, start servers from scratch and set up your model serving service, to not have to worry about service, servers or compute resources or anything at all, and just copy, essentially paste your function in a, in a solution like, like Lambda functions or Google functions, Cloud functions, or in between where you use containers and do a little bit of DevOps work. Okay. So is that clear? Anybody have a question in what's the bigger picture here? So the goals for today is to, at the minimum, understand what Docker is. How can I start, some beginner introduction to how to start working with it, and some introduction to what is called Elastic Container Service. Okay, so that's the two new pieces today, and we'll kind of revisit Lambda functions, an instantiation of a serverless solution from last time. If you have any questions, post it on the chat. I'll keep the chat window on the side. Okay. So let me share my screen. Okay, so recall from last time, we were looking at serverless deployments, which essentially manage solutions, and we were looking at cloud functions for quite a bit. And then,
Professor, sorry to interrupt you. I texted you on Slack also. The previous lectures recordings are not accessible on Blackboard.
yes, so the previous lectures recordings are somehow misconfigured and they're showing up on a different course. So the
Okay.
previous lectures I can download from the other side and share it with you. But I think you can anyway view it because the links are on Slack.
Some links are, sorry?
The lecture 1 and lecture 2 links are on Slack.
Okay.
They have been on Slack since the lecture finished. So you can always access from there, but
Okay.
I can try to figure out how to get them. I can just download and upload it on a more convenient location for lecture 1 and lecture 2. Yeah.
Okay.
But
Thank
you can
you.
always view it from Slack. Okay.
Okay.
The main channel has it.
Yeah, I joined recently, so I wasn't aware.
Okay.
Thank you.
Any other questions? Please do interrupt or post on chat. Although where's my chat window? Okay, I can see chat. So in case some question pops up, I can address it. Okay, so let's go to Lambda functions directly. So it's going to be a walkthrough. So if you have, I don't know how many of you have tried working through the lecture notes, basically, because they're quite practice oriented. If you have already tried Lambda functions, then this is going to be a recap for you guys. So before that, I just wanted to point out that there is a additional page called exercises where you can try slight variations of what we're trying to do today. So trying to do in every lecture. For example, in lecture 1, when we self-deployed this model service, right? A server which would which would respond with predictions. We were using Flask as a choice, but instead of Flask, there are several others, and so you can try using others. And instead of, like, I use Vultr as a virtual service, virtual private server, but you can use other vendors if you want. So in lecture 2, we have we looked at GCP Cloud Functions, and so and the API gateway. So you can also try to use, if you have a custom domain, to link that custom domain to that service if you want. So these are all additional things which are not really related to model serving at the core. So that's why we're not covering them in detail. Okay, and you'll see that from last time and this time, some parts we were using command line, functions. So command line arguments and sorry, not command line arguments, but we were using the command line to execute some operations like. And we'll see some today as well. But you can do the same thing via the GUI, as in via using the browser on using UI on the AWS console or on the Google Cloud Console. Okay, so just some things to keep in mind. You can also try deploying a different recommendation model as well. So we've been using, and we will use today as well, a certain model that a certain model built in PyTorch, as well as using a particular Python library. But you can always change the model prediction service. So all these variations will show you where there are parts which are tricky, or will give you practice. Okay, let's jump to Lambda function. So as it says, Lambda is by AWS, and it's basically an analogous serverless solution. So there's going to be some differences with Google Cloud Functions. So I'm going to point them out as we go along. Okay. So we will Okay. So we will set up. So last time what we did was we started an Hello World. We went through very quickly a Hello World app in Lambda function. So let's just redo that. Oh, sorry, this is pretty loud. Oh, okay. Yeah. So let's go to services and go to Lambda. So creating a Hello World type of application is relatively straightforward. You just go via the UI, basically author from scratch, give a function name, test, that's it, and choose whichever Python version you want at the runtime, and okay, we can use a new role for this. So let's create the function. Okay, so now we can see the function. So the important thing is the function is very simple here. It's just importing JSON, and JSON is only needed because as a response, we're dumping out a string, and we're going to give a JSON response. Okay, so that's so JSON is, think of it as a Python dictionary, essentially serialized, and so that's the only function present in this hello world example. And if you look back to the notes. So I chose Python 3.7 there, but it's 3.8 and 3.7. So there will be incompatibilities with 3.7, 3.8 sometimes. Um, okay, so what I said last time was you can create a simple test here. So configure test events, and so you can give a name, test1, and it doesn't matter because we don't need any input for this function. So we created a test event, and you can hit test, and you can see the execution results here. Okay, so response is exactly what we wanted to. So the whatever the function is returning, status code 200, body, is essentially a string here. Okay, so that's a very quick testing, and so the difference. So let me point out the differences with Google. So the cloud functions is that you see that in this interface, at least you cannot specify a requirements.txt. Okay, so in cloud functions, we could specify, here we're importing JSON. JSON is already is default and included module, so you don't have to install it. But if you want to, let's say, install PyTorch, if you want to use pandas as a part of your service, and if you want to use serverless solution like this, then there is a little bit of a more involved way of introducing those packages. Okay, so that is one step, one difference here, and let's see. And I mean, the results from the test can also be seen here. But what we care about is accessing this API from outside. So let's fix that. And then we're going to change this from hello world to actually the weather service variation or model serving variation. Okay. So if you, so let's, I guess, minimize this or close that. and then we have to add a trigger. And here we're going to choose API gateway. So this is where you can let this particular function get triggered by an external request, like a HTTP request, and that's what we'll choose. And security, for now, we'll just keep it open. There's something where there needs to be some deliberation, not so much from the model service point of view, but from the overall business perspective of how permissions and security is organized. Okay, so we're not going to change anything. Okay, so once we do that, we get a green bar saying that just test API, which was the name by default given by that UI, was successfully added. So you can see that link here to the test serverless Lambda function. Okay, so once we click on this API, so go into the details. And so this is the endpoint. Okay, so endpoint is just the URL from which we chose open, so anybody can access this particular URL, and you'll see hello world essentially, or hello from Lambda. Okay, so basically you need those two to get the those two to get to our function to trigger, and it triggered and responded with something. Okay, so so that's good. Now, I'm wondering whether we should do the weather app, which is there in the notes, or we should do the other recommendation. So I think the recommendation will be more complicated. So let's do the weather app. Okay. So, okay, so I think just like in Cloud Functions, we used Google Cloud Storage as a way to store the a model file, as well as some, I think last time we had a metadata file as well, and we were reading those two from Cloud Storage. But as somebody pointed out, we were actually dumping it to a local temp directory first, and then reading it from there. And there was at least no clear path to directly read into memory the model file, the model, the prediction model file, as well as the metadata file. So similarly for Lambda, there is a way to set up our Lambda function by, let's go here. So if you look at the test function, you can actually go, if you look at the top right side of this function code, there's an action which says upload a zip file or upload a file from Aws S3. Okay, so sorry, yeah, S3. So let me quickly discuss S3 first. So S3 is I think it stands for Simple Storage Service. So it's basically storage for AWS, just like Google Cloud Storage, and we'll have to set up a programmatic. I mean, we don't have to, but it's good to set up a programmatic user to access S3 so that we can, if we are doing some local development on an EC2 machine or on our own local machine, and we produced an artifact like the model file, we trained for several hours, and we got a model file, and we dumped it to disk currently, let's say on EC2 or on our own local machine. So we need to push that to S3. Okay, so to do that, we're going to create a S3 a user who exclusively works with a programmatic user. Just like, remember for Cloud Functions or Google Cloud, we had a service account and a user account, a regular human account. So similarly here we'll have a programmatic user, and that user, using a user, we can dump our model and metadata into S3. Okay, so and in particular, we'll try to get the Lambda function by first dumping our files to S3, and then reading it from S3. So actually, if you look at here, it says upload as a file, or upload from a file from S3. So upload as a file would directly just, we'll skip the S3 step and directly upload the things related to our model deployment or a function deployment directly from our local disk. Okay, so but this is a little bit more manual than dumping things to S3, because there at least there's programmatic ways of dumping it, and you don't have to interact with this interface, for example. And you can update S3 with multiple versions and falls into the AWS ecosystem. So let's first create a programmatic user account. So let's so this test function is fine, but let's go to services. And for now, go to IAM. Okay, so we already have few users. Okay, let's add a user. S3 user and programmatic access. Yeah, so that we can use AWS CLI, for example. Okay, so next. What we're going to do is instead of using some, instead of adding a user to some group which have some accesses, let's attach a policy which is related to S3. So the policy we'll choose is Amazon S3 full access. So there are many policies, and how do I know which policy to pick? You read the documentation; it'll tell you Amazon's documentation will tell you which policy to attach to a particular user. Okay. So there are two types of accesses for S3: read-only and full access. Full access where you can create and delete files. So it's I guess more permissive. So we're not going to do tags, but it's very useful in large organizations. And review. So we have a username called S3 user, and so on. And I think what I'll do is just unshare for a second, because it's going to show me some access keys, I guess. So I'm just copying. So in the next page is just showing access key ID and a secret access key. So we're going to use that. Yeah, so we just created this user, S3 user. Oh, this is not well formatted, but yeah, so there's this S3 user. Okay, so and if you click on it, you know what permissions they have. Okay, so now that we have the S3 user, so we can go to the command line. Let me show you that. Okay, so first of all, it's not always necessary, but it's good to do this. Activate the environment that you will install packages and so on in this. And so if you're working on a project, it's always good to get into that environment as soon as possible. Okay, and then AWS. Have we configured AWS last time? I don't remember. Oh, actually, I have not. So this is good. So we just got the access key. Oops. Okay, access key is not very critical, but let me just insert that. And so what I'm going to do, what I'm doing is inserting the access key and access secret key, and I'll show it to you again in a couple of seconds. Okay, let me come back here. Yeah, so I did AWS configure. So I added the access key that I got in the earlier screen when I finished setting up the programmatic user and some secret key. And I just chose a region name. So there are regions associated that you can look up. So by default, you generally be assigned to use East 1 or use East 2. But there are many, many regions. This will become important if you care about latency and where your customers or end users are. Output format I just chose JSON. Okay, so that's AWS configured. So it's something so that so it's basically ensuring that this command line utility can now talk to your AWS account. Okay, under those permissions given by this access key and access ID. So it will pretty much be restricted to S3. Okay, now let's see. So how did I get to CLI? So it's not by default installed in your terminal. So you have to install it from Amazon CLI. Sorry, this, let me see, there's a link. Yeah. Yeah, so this is the link, aws.amazon.com/CLI. So I'm just showing you this because we could have done, we could have uploaded things to S3 from AWS website, and I probably will quickly show you that. But we're going to do it programmatically. Okay. So with that, and this is what I showed just now. Oh, okay. I'm not showing the appropriate screen. Okay. Yeah, I was just saying that I just navigated here, and I was just showing that this is the link from which you can download AWS. Okay, so the AWS CLI utility. So CLI just means command line interface, and you can get it for any of the operating systems you have. Generally, what I'm doing right now, when I show the terminal and so on, I'm just doing it on my local machine. But there is absolutely no difference in terms of doing it in an EC2 server. So your machine may have lots of incompatibilities, may not have space, or you don't want to really mess up your local machine with a lot of utilities, then you can always do this on a machine from EC2 or any of the other service providers. Okay, so you can download it from here, the command line utility, and then if you type AWS configure, once you install it, it'll be in the path, and just configure it, and then let me switch back to the terminal. Uh, okay, AWS S3, and then if I do ls, then I may have, so the buckets that I have um, are shown here. So these are the two buckets that I have. So there's already a bucket called Teja-model-store. We can actually create buckets on the fly. So for example, AWS S3, and then make bucket. And then this is the so S3 :// and then you can give a bucket name like IDS 594 bucket, right? So this will create a bucket for us. So what is a bucket? It's like a container. It's essentially, as the name implies, figuratively, it's a container which will have some units of objects, and those objects can be like, for example, model artifacts like the trained model or model metadata or data itself, training data and so on. Okay, so 12-month free subscription on your account, but they start charging you based on the number of requests. Yes, so somebody asked about what's free tier eligible and what's not. So you can actually go back, I think. You can look at billing. Okay, I don't see it here, but I think, here you can go to billing and see what is free trial eligible. So they'll tell you, and they'll actually show you what's eligible or not. So actually a part of today's work, like the Elastic Container Service, that's probably not free trial eligible. That just depends on documentation. But yeah, you do get, so EC2 machine, for example, the T2 micro, I think that's the instance type. That is free trial in the sense that you can keep it on for throughout the 12 months and you'll not get charged. Okay, at least for the compute side. Now ingress and outgress of data, like the bandwidth, there may be charges beyond certain limits. That's a great question. So we are not paying too much attention to billing at the moment, but certainly do not try to tear down everything that you build. If you're just experimenting with it and you know you're going to tear out, you're going to close everything that you started, that's fine. But for a longer term activity, certainly evaluate costs. So as I said earlier, DevOps, first lecture DevOps stuff, it's going to be the cheapest, right? You're just using the EC2 instances and doing everything by yourself. Serverless variations that we're studying today, as well as the last lecture, they're going to cost you some money. And in between, you can do a partial DevOps using Docker and Docker and other orchestration tools. So there's going to be costs associated with not just the options, but also what all resources are consumed while executing those options. Okay, and there are many other resources that we are not talking about, like networking, using a static IP address, monitoring, like something like CloudWatch, I think is the name of the service provided by AWS. So there will be charges associated with them. Let me go back. So we have the S3 bucket. Now let's store the model in the bucket. So now what we'll do is actually switch over to the interface. Okay, let's go back to the interface here and go to services. Oops, yeah, so let's go to S3. And as we saw in the command line, there were three buckets. So yeah, this is just to see, I mean, okay, I didn't want to demonstrate, but you can also create a bucket here, the same thing, and you can give a name, which I just gave earlier, which region do you want it, and these are all the regions that you can have the storage service at. I'm not going to do this. I think we can just move to zip of the local environment. So what we need is actually a, as I said in Lambda, so S3 is done. So we have a bucket. We can just dump our serverless related files there. But before doing that, let's go back to Lambda and get a sense of what we're trying to do. So if you go back to test, what we're trying to achieve now in the next few minutes is, because there's no way to specify the requirements.txt, like, okay, if you needed Flask, for example, Flask itself is not there. So we have to somehow get, whatever function and Python script is here. If it imports Flask, if it's not there, if it's not installed in appropriate runtime, we'll have to somehow install it in the local directory. Okay, so that's what we'll try to achieve. And okay, so let me see. So I'm going to try to create Python functions from the notes from the web page. So bear with me for a second. Okay, So if you look at the code that I wrote, okay, which I should, let me share and discuss. Oh, actually it's there. Okay. So if you look at the code that I've written here, so here is again the description of how to make a bucket using S3. So this is all fine. So if you go to this topic in fifth section, which is zip of local environment, you'll see some changes. Okay, first I'm gonna try to create a zip which will not install any local packages. So why am I doing that beforehand? Is that if you look at my model serving function from before, um, let's say, let me go to section 3. I just want to take a sneak peek at this serving functions. Okay, so so if you look at GCP's Cloud Functions, there was a requirements document which had all these packages, right? Now, if these packages were needed on the serverless on Lambda side, I would have to locally install them in a directory, which I'm going to discuss now. Locally install it, as in like get these packages locally, and then zip up the directory and then upload it to S3 or upload it to the serverless option. But turns out that if I locally install them, and I'll show you how to install these guys. If you locally install them and zip up the folder and upload it, it turns out that the size of the zip or the size of zip is large, and serverless does not allow me to execute that into a serverless function. In the sense, not execute that, put that in a serverless function. As in, I hit what is called, I guess, serverless functions have to cannot be more than 256 megabytes in size. The zip or the whole directory size, actually, what is it? Unzipped directory size cannot be greater than 256 MB. Okay, and I just hit that limit. And so what I did was, instead of doing it the way I did it in GCP, we're still going to make predictions. But what I did is do a little bit of pre-processing. So I created this, I'm going to create this folder and I'm going to show it to you soon. But instead of installing all those additional packages like Surprise, Pandas, and so on, using these packages, what I create is an intermediate file called, an intermediate file, which is, did I skip it? Where the objective should be to create an intermediate file called top-end.json. So so what I'm trying to do is, in these two blocks of code in the zip part, is to create a directory. Okay, but in the directory, I'm not going to include this file, but this file is just pre-processing my model and the metadata to create. I think there's some part which I just missed here, but it's trying to create a JSON file, and that JSON file is what I'm gonna use along with a an appropriate Python script. The JSON file and the Python script is what I'm gonna zip up and send to S3. Okay, so just to recap, my objective here in this section is to zip up a JSON file of predictions, of all possible predictions for each test user. Predictions in the sense of movies that they've not seen, along with the script that's going to actually make the prediction by reading that JSON file. So that you can see here, the function that I'm going to use is a Lambda, it's called Lambda handler, but it's just going to read the JSON file, which is top-end.json, I think. So top-end.json, as well as movie.json, movie metadata.json. So the two JSON files which I'll read, and from that I'm going to make recommendations. So for this, all I need is JSON, and JSON is already there, so I don't have to locally install anything. But if I had to locally install, then this is the type of command that you would use. So remember, from the GCP Cloud Function side, there was some requirements.txt that had, for example, Flask, right? So how would you install Flask locally in this directory to zip it up? You would do pip install Flask -t dot. Okay, dot just means the current directory. So that would install Flask locally in your directory. But I'm not going to do that because the overall zip file is too large for the serverless demonstration. Okay, and that's one of the limitations with serverless. So you have this size trade-off, and you will not have the size trade-off if you move to Docker. And we'll do that soon. So okay, let's do this. But do I have these files? Okay, let's see. Okay. Okay, actually, yeah. So creating from, okay, I'm trying to figure out where to start. For this, we need a surprise model and movies.dat. Okay. Where is the, so is the idea clear? If anybody has a question. Okay, yeah, there's somebody, this was a question, sorry. If the JSON file consists of all possible predictions, how did we resolve the problem of memory which occurred due to large size of packages? So the packages are taking, so for example, pandas requires NumPy. And so NumPy itself is 100 MB. And you'll see that, I mean, so in my example, it turns out that the if I'm doing all possible predictions, it's actually pretty small because I have about 1,000 users and about 1,000 movies. Okay, so it's basically a million numbers, and actually it's not even it's a million numbers basically, and that's smaller than the full NumPy package, the full Pandas package, and many other packages that you need. Okay. Not too many, but you would need some. I hope that answers the question. You can certainly try. I think PyTorch definitely will not work. So if you install PyTorch, it will need you will need a lot of packages. So and then I thought I'll install this, and even this one I think I found space issues. Maybe you can try it and you'll not find a space issue. But anyway, 256 MB is the limit for the how big the unzipped directory can be in the Lambda function, the local directory. So we are in which directory? Okay, let's go to desktop. Model. And what I'm going to do is just copy the dumped, the trained recommendation model, surprise underscore model. Remember from lecture 1 or 2. I'm going to just copy that and the model.dat, and then we're going to make it into JSON files. Okay, so let me do that. And what is it? Surprise. Okay, so I just copied it from another directory. So sorry, this is a folder. So these are the two things. So actually, let me run Jupyter Notebook to convert them into the JSON objects, so that we don't have to look at the terminal all the time. Okay, let's create a new Python 3 notebook, and let's copy the So I'm just copying the code from the web page, and there is some issue with formatting, which is not good. But let's do that. Okay, I didn't need to do this. I could have used from collections define defaulted. So let me just read the file from using pandas. This is a metadata file which gives given the movie ID, it just tells the movie name. Okay, and it also tells you the genre, but we don't need that. And surprise model is what we have trained already, so we can see that by doing. We already have these two files. Okay, this was trained from before. Okay. We can retrain it, but I don't think it's necessary. So we have that model, and then there's this function get top n. We're going to make predictions. Okay. So another reason why this top n JSON file is small is we're only storing the top 5 predictions for each user. Okay, it's a good question. So if we were storing all 1,000 movies or something per user, then it would probably be a little bit larger. So I'm dropping genre, converting to dictionaries. I don't think we need these pickle files. So we're gonna import JSON, and I don't know if it's already imported. It's imported actually. So JSON dot dumps. Actually, I don't remember the. Yeah. I think I'm trying to remember what's the format here. I think JSON dot dumps. I don't know. Okay, the second argument is the file. Okay, so we can just do this. Now I'm not taking out the text. Movie dot JSON. I think it's what was the name of the where is our oh yeah, I was just trying to figure out like what's the name of the file. Movie underscore dictionary and top n. Okay, so let's go back here. Which is what we created here, and same thing. Okay, so if we run this, I don't know if all these packages are there. It's not there. Great. So surprise. I think there's a Conda installation way. I hope I started this on data sci environment. If not, it's okay. Okay, so what? So once we dump these two files, we're gonna zip up the folder which has the this file, this file and the two JSON files. into a small zip and then just upload it to S3. And then from S3, we're going to read it to the Lambda function. So wants to install, and there was a command line argument. I should have used -y. I don't know. Okay, it's taking a little bit of time. So in the meantime, let me just create that file. I'm just going to name it Lambda Function.py. It's basically a copy from, wow, what is going on? Okay, let me stop it. I'm just installing it from the command line. It's the same command. And it looks like the installation is going fine for that library. So even surprise lib requires NumPy, and once you install NumPy, it's already consumes. It will consume quite a bit of space and compress. Okay, so it's installed. We can restart the cutoff, and oh wow, we don't have formulas. We need this. Okay, I don't think we need this. Okay, so bear with me for a second. I'm just installing pandas and the other packages locally in the conda environment. So I'm in the data side dev environment, so everything is restricted to that. So any questions in the meantime? Okay, it looks like all the packages are installed. So let's drop this. So we're reading the model file, we're reading the metadata and creating it into formats so that we don't have to install the same like surprise or pandas package it into a folder and put it onto the Lambda environment. Okay, so these are heavyweight packages, so I'm just trying to avoid that. That's the difference between the Google Cloud Function deployment and this one. So I think we ran and we have the appropriate dictionaries in this. So that's great. So if you look at this, so now we have Moby JSON, top end JSON, and I also created in the meantime a function called lambda_function.py, and you can actually look at it. It's basically the thing from our course webpage. So it's basically just doing import, but it's reading those two JSON files. So the import is only JSON, and we don't really have to package anything. So what I need is I will need to zip up these two JSON files and the Lambda function into a zipped file. So let me do that. So before that, let me just so I'm gonna go into that folder and just move unnecessary files from there. Okay, so I just moved it. So if you again look at this, or even this file is not needed. Python notebook. Okay, so let me before closing it. Yeah, let me close it. And actually, on Jupyter, you can also open a terminal. So if you look at the folder, we have these three files which you care about. This file we don't. We can always zip it up, but I think I'll just move it to another folder. And now, yeah, zip, yeah. So zip some file name run.zip, then start. And so we got that file. Okay, this is a zip file. And so we have to push it to S3. So let me just recap what the S3 specific commands were. Yeah. So the commands are there in that again in our in our serving, I guess, page. So we got that. So I'll also want to point out a couple of things. This Lambda handler is taking two inputs, event and a context. Okay, and our if you query this model, or I guess now it's not really the model, it's just storing the predictions. If you query, the query will be present in the event object. Okay, so the event, so we have to search in the event object if there is a body, and so within the body if there is a JSON payload. Okay, so we just have to copy the zipped up file into S3. This is not the right bucket. We just created a different bucket. We're going to change it to that, and then the zip file. Okay, so let me just execute that here. I wonder if I can do that here. Oh yeah. So okay. So let me. Oh, it's gonna override it over there. Okay, we can change it to the other 94. Now I forget what's the name. Hyphen bucket. So let's do that. So we've copied it, and to double check it, we can just go to that bucket, and we just uploaded it. Okay, so we have that uploaded thing. So now let's very quickly go to services Lambda and create a function. We'll choose 3.8, and this is gonna be the command, and create function. Okay, so now what I'm saying is in the actions, we'll upload a file from Amazon, so AWS S3. So Uh, oh, I thought the URL was slightly different. Let's see. Okay. Okay. Let's just do S3 colon the bucket name. See. So, I mean, when you save it, you will see that the 3 files are already here. These are 3 files, and this is the function. Except, let me see if everything is. No, I think the formatting is messed up. Okay. So we have this, and open those 2 files, load the files. And then, I mean, we can actually load the file outside, I believe. So somebody can test that offline. Okay, so this is just debugging, don't need it. And yeah. And so you will also notice that I slightly changed one more thing. So if you look at the body, I read those 2 JSON files. And then once I get the event, so when I get a request from HTTP and I check that the event is not none, I do a JSON.loads. And then I check. So I'm basically just replacing the event object with a smaller object within it, which is just the JSON part. Sorry, I'm making it into a dictionary essentially. And then uh, I'm just checking for a key in the dictionary, which is UID, which is the user ID. And for that user ID, I'm defining as I'm just using the metadata. So I'm creating a string, and the string is just a list of movie names. Okay, so creating a list of uh, movie names for all movies which are top end for that UID. Okay, so event.get UID, I could have just done UID, dot bracket if needed. So that's what I did. And so this is just a string of movie names relevant to that user, okay, which are my predictions from my model. And then I'm just returning JSON dumps, which basically creates the dictionary to a JSON object. And then I've also added headers. Okay, so this headers will be useful. May sometimes give you errors if you do a local test and then a test with the browser. So that's the upload, and we don't have to change anything because I just chose the function name to be what the default function is. What was there in the hello world function. So let's now create a test. Come and test. And then let's give a, we can have more keys, but the key that we care about is user ID or UID, and that we can give some number like 20. And this is a JSON request, so we created this. And if we do a test, let's see what happens. Response error. Okay, there's some indentation issue. Expected an indentation at line 7. Okay, let me copy this into local IDE and see what the indentation errors are. Ideally, I didn't want to do this, but okay. Okay, let me fix that indentation in a breaks because we're already an hour into it. So let's resume at 7:48, and in between I'll just fix the indentation. Let's take a short break here. And if you have any questions, just post it on the chat. Okay, so I think last time when we left off, there was some indentation error, but I just rerun it again. There was a couple of commented lines here. I just deleted it, and it seems to be fine. So let's test it again. So execution details tested, status code as expected, and we are returning the status code. That should be fine. And sorry. And these are the recommendations for, I think the query was for user ID 20 or something. So the response is these are the movies. Okay. Now let's actually, so internally it's working fine. So, and there is no size issues because clearly these three files don't even add up to 1 megabyte, I think. So again, we can add a trigger. Using an API gateway. And for now, create an API. Security will be open again, and just add it. And then go to the details, and if I click this, success is false, so it's the resource is working. But ideally, you would want to use requests to do this. But actually, I think we need requests. Let's try this. Okay, I think we need to provide a JSON payload or use Postman. So let's see. So I'm starting up Postman. So, okay, so this was, oops, sorry, the link is this, and the body has to be, oh, okay, we actually gave, okay, so we got a successful response. I think previously what we given 20. You'll see that if I give, there is actually in the script, there is no, the script is not robust. For example, if I provide a UID, which is 2000, I don't think it should work. Let's see. See, internal server error. So these checks are not there in this rudimentary script. Script that we are serving as a serverless function. So one exercise could be to add these types of checks. Okay, so whether the user ID is present or not, and so on. So for now, I think if you guys want to try it, I'm just going to paste the URL in this live chat box. You can, but you'll have to do a JSON payload. So it's not as simple as doing a get, arguments. Okay, so you'll have to use something like Postman or the requests module in Python. Okay, so now, so that's good. So we have finished working with AWS as well, Lambda functions as well. So any questions about this part overall? There are some, minor, so most of the effort is actually just getting things going. I mean, in terms of concepts, we already covered the concepts of what serverless deployments are, and it seems intuitively easy to understand, but to work with them, you need to look at the documentation at some point or the other. So, and those are the quirks we fixed today with Lambda functions. If you have any questions, post it on the chat. If not, I'm gonna go to lecture 3, which is about serving models using containers. So first we'll talk about containers. Hopefully we'll get, we'll see where we can get to, and then talk about an orchestration of containers. So first we'll talk about a single container. A single container will contain our model and we'll serve it. And then we'll move to still a single container as an example, but we'll use an orchestration service on AWS for today. Okay. So what are containers, or what's the problem we're trying to solve? Again, from first lecture, and in fact, in these lecture notes, there is this compatibility issue with Pickle and Pickle 5, for example. So that's just one instance. But the environmental compatibility is always an issue. In addition, you care about scaling depending on number of users you have. You care about security. All the things that come with DevOps issues, like even the hardware could fail or the software could arbitrarily update to some versions which may not be compatible with your program and so on. So those are the issues. And for hosted, we know we have to work hard on DevOps, and for serverless, most of this is taken care of by Cloud Functions or Lambda Functions. But still, they are limited in the sense that you saw for Lambda Functions, there is a limit of 256 MB. And if you wanted to serve a PyTorch model, you can try as an exercise. It's going to be a little bit challenging. Okay, so it's a good exercise to try, because we already have a PyTorch model training script in lecture 1. So download it, train it, get the PyTorch model, and try to upload it along with the PyTorch package. You'll see that the package size is too big. So for issues like that, we can have an intermediate solution, which is containers. Okay, containers essentially, as the name suggests, it's like a box that inside the box you can run your arbitrary programs, because you are specifying everything that's needed for your program, and this box can run in any other piece of software. And that the box and its interface with the rest of the software, like Linux or Windows or Mac, is handled by another piece of software like Docker. Okay, so what's the use case? It's basically, it's quite very it's pretty popular in web app deployments, and you'll see a lot of software packages if you want to try these days to also tell you how to download a Docker image and run it in a Docker container. Okay, so that you don't pollute your local environment whenever you want to try out a piece of software. And our objective for this course is going to be model deployments, and we're going to do that today. And other use cases include packaging up your whole project as a snapshot and archiving it. So the next time you want to get back into this project, you just have to open up your image. Instantiate your image as a container and get into it. So you don't have to again manually figure out what's the project requirements, like a software project requirements, and do that. Okay. So that's the general problem and the solution. And containers specifically, as I said, are ways to have a reproducible environment. There's also additional things like you isolate and package everything that your program needs, independent of where your program is running. So of course, there's an in-between layer, and that's, for example, captured, serviced by Docker. So a container is essentially a process. So a process is like a program, right? So a container is essentially a process. And because it's a process, it's much more lighter weight than a virtual machine. So many of you must have, oh, I can't see my screen. Can you see now? Oh, there's no slides. Sorry, I'm just talking with my. Oh, you're seeing my Postman. Oh, good point. Yes, that's a good point. Um, yeah, good point, good point. So yeah, sorry, I was just going over from the top of this page, section 1 of lecture 3. So I just mentioned the problem and the solution, like where do containers come in, right? So it's just they allow you to run arbitrary programs in new environments without worrying about what that new environment is. It could be a Linux system of multiple varieties. It could be on AWS or GCP or somewhere else, and still you should be confident that your thing runs, and that's enabled by a container technology. Okay. So that's what I was mentioning that containers are essentially a process, which just means it's a program. So it's different from a virtual machine in that regard. A process is any. For example, when you compile a C program and run it, it's a process. Okay. Um, so virtual machines, many of you might have used. If not, try it out. You can use VirtualBox or VMware Fusion to set up a virtual machine and play around. And you'll see that it's a little bit more bulky. It does give you a lot of the features that a container gives you, such as all the benefits that I mentioned earlier. Um, but you'll see that containers are more lightweight. Um, and another good thing about containers is more about collaboration. You can actually pass on your images to other folks, and they can create containers from those images, and they can have the same environment running without kind of circumventing all these incompatibility issues. And if you look at many of the GitHub packages, GitHub repos, and if you look at the issues on GitHub repos, you'll see that good chunk of issues are about incompatibility. Oh, I'm running Python 3.8, and your thing only runs on Python 3.5. Okay, so this is a constant fraction of many issues, so you can really circumvent it if you can use a container-based distribution of your solution of your program. Okay. One variant of this container-based technology is Docker. There are others, but we'll not kind of get into other solutions. Um, so in summary, containers are useful because they are consistent. Your app development as well as delivery is in the same and runtime which you control. It's portable, so you can run the same container in local machine as well as in the cloud, and it's quite lightweight compared to virtual machines. Now, in addition to containers, we'll also look at ECS. Okay, so Elastic Container Service think of it as a management tool which manages containers. So it's a proprietary solution by AWS. So we're only looking at it because it's a popular option, and you'll get a sense of how containers are. I guess the right word is here. It's called orchestrated. How containers are managed. So so ECS is the short form. So it's similar to Lambda functions and allows one to be agnostic to, so basically even container technology and then therefore the orchestration stuff. It allows you to be agnostic to DevOps issues like which server, what is server configuration, whether the server security, other servers are updated, and so on. Okay. You are able to be agnostic to that to some extent. Depends on the orchestration solution that you use. For example, ECS, or on the Google side, Google Kubernetes service. Okay, Kubernetes engine, GKE. But anyway, so we'll get to those orchestration aspects later. For now, for example, there are some restrictions from Lambda functions. Right? I just said there is a limit of 256 MB on the directory size. And you're not also restricted to the specific runtimes that are available on Lambda functions. So if you looked at the drop-down menu, it had popular runtimes like Python 3.8, Node 10 point something. But if you have a specific requirement, serverless solutions will not be, may not fit the bill. So, while exploring ECS, just a note, while exploring many things in this course, especially managed solutions, keep a tab on billing, especially, you'll be fine as long as you close everything and remove all the instantiated services or resources that you use. And so, okay, let's move forward. So what we're going to do today is try to start experimenting with Docker locally. I think we'll skip running Docker on EC2 specifically. EC2 is going to be very similar to running it locally because EC2 is essentially a machine, a single machine, which is what I was referring to here. I think after Docker local experimentation, we're going to push it to ECS, okay, on the AWS. And it's good that we were looking at AWS in the last hour so that we continue to stick with the same provider for the rest of the session. What's the end goal is that we want a functionality that is almost serverless, okay? So as I keep repeating through this lecture, we are in between serverless, which is essentially the topic of last lecture, lecture 2, and self-hosted deployment, which is lecture 1, in between. Okay, so that's the solution we're aiming for. So let's jump to Docker. So there's a lot to, I mean, you can certainly go over Docker's documentation and the Docker's webpage to get a sense of what Docker is. Docker is a way for, as they say, it's written in Go, and it's for developing, shipping, and running applications, essentially managing containers and allowing you to define an appropriate artifact, which can function as a container, and so it can run in other environments. Okay, so what can you do with Docker? So you can basically create a loosely isolated environment, and that's what a container is. And you can run, and this is something that I didn't mention earlier, you can run multiple containers on a single host. Okay, on a single machine, you can run multiple containers. They're all isolated with each other, and they're all just processes. Okay, so okay, so let's look at an example. So what are containers? As I said, containers are lighter than virtual machines, and that's because they run directly with the host machine's kernel. The kernel is actually just is the core of the computer's operating system and controls pretty much all resources on the system. Okay, so basically a kernel is just this: a CPU, memory, and devices are resources, and the kernel interfaces these resources with all the applications. So that's what a kernel is. And containers are lightweight because they directly work, they run directly with the host kernel. Unlike virtual machines, which will be at the application layer, they themselves create another kernel over which there will be the apps. Okay, so all I'm trying to say is that containers are faster compared to VMs. But at the same time, the amount of isolation you get in VMs is higher than the amount of isolation you can get with containers. So let's go to Docker. So we're using Docker as a word, but it's actually an app or an application which has 3 parts. Okay, so there's a part which is a server, and that's what we'll get. So that's what we'll get when we install Docker. So you can, I think I mentioned Docker installation below, but you can go to Docker, I think docker.com. Yeah, and you can just get Docker desktop and explore it. Okay, and I'm just describing, so once you install that app, when let's say you double click it on Mac and install it, you'll actually get 3 things. Okay, one is a server, it's a daemon or a server, which handles creating, it does everything about containers. And there's a utility or a command line interface, a client, which interacts with the server to help you create containers. Okay, those are the 2 things. And the way these 2 talk to each other is through a API or an application programming interface. And so there's a standardized language to talk between them. Okay, so basically you have the Docker daemon, which actually does everything, like create containers and everything like that. The client utility, CLI, so that talks to the Docker daemon and helps you deal with containers. Like you can create a container from what is called an image, and also deal with if there's a container, there'll be some network access that it may need, or it may need access to a file system or a data volume or something like that. Okay. So those are the 2 components. So when we say talk about Docker, we're not really talking about the Docker utility, which is the CLI interface. We're talking about the server which helps handle and create your containers. I mean, yeah. So here's the architecture again. So the client is on the left side, which is when you install the app from docker.com, Docker for desktop, for example, then once you install it, you on your path, once Docker is on your path, you can just do Docker commands. Okay, Docker build me a container, or Docker, build me an image, or Docker run a container, or something like that. Okay, so these are commands that the client does. So these commands go to the Docker daemon or the Docker server. And the server is the one which kind of manages, if you want to pull an image like an Ubuntu-based container, then it goes, talks to some repository and gets the Ubuntu image, creates a container, and stays with that. And for this Docker daemon, the server may need to talk to a Docker registry, for example, Docker Hub or something like that. So the extreme right side, the box, the registry, is just a public index of all the types of images that are available from which you can create containers. And of course, you can have local images from which also you can create containers. So that brings to the next topic, what are images, right? So for that, let me specify. So here's the architecture, right? So let me tease out the architecture a little bit more. So we said there's a client and there's a server. Okay, once you install the Docker app, essentially you get a client and a server. The server does everything, creates containers for you, and client is just to talk to the server to make you create containers or make you create what are called images. And I'm going to tell you what images are. To do those things, the server has to talk to a registry. Okay, a registry is just a public index so that it can get the at least the starting points. Let's say if you want to create a environment or a container which has all the Ubuntu utilities, then you would want to base it out of a Ubuntu-based image. Okay. So Docker registry is a repository for Docker images. Now, what are the other objects? Images, let me name a few. Images, networks, containers, volumes, sorry, there's some spelling mistakes here, and plugins. Let me focus on image. Okay, what is an image? So the image is essentially a read-only template of instructions to create a container. So image is like the starting point. So from an image, it's like a class, right? From a class, you create an object. Similarly here, from an image, you create a container, okay? And you can destroy the container and again create another container from that or starting image, okay? So an image typically is based on other images. So your starting point could be an image of Ubuntu, some version 20.04, and then you can build an image saying your solution image, okay? And then you can distribute that image to your colleagues, and your colleagues can create containers based on that image, and they will have the exact environment that you have, for example. So, so Docker file is a file which can create images from, okay, so a Docker file is a file which helps you create images, okay? Help create these read-only templates. And I'm gonna show you pretty soon some of these. Okay, and let's say you ran some command like this. This is a client-side command. It says Docker run, okay? So this Docker run command is basically doing several things. This is just an example to understand what is going on behind the scenes. So when you run this command, okay, so it's pulling an image from the registry, like Ubuntu or Ubuntu latest or something. From that, it's actually creating a container. So it's going from an image read-only template to a container. It's actually creating a file system and a network interface, all behind the scenes. And then it's letting you execute a command within that container, which is bin/bash, and letting you access it. Okay, so that's what an image is. Now, let's not worry about services. It's just a way to manage multiple Docker servers together. And so this is not very critical at this point. So let's jump to container. So we just described image. Image is essentially a read-only description of what a container should be. So a container is a runnable instance of an image. So it has several operations. So your Docker client utility can do several operations on it. Operations to work with a container. For example, you can create a container. You can start a container, stop a container, move a container, or delete a container. Okay. So when you delete a container, it's gone. It doesn't store state anywhere, and so you need to be careful to dump the data out or deal something to do something with persistence. Okay. Virtual machines actually have an additional thing which is called a hypervisor. So this, I guess, explains more about why containers are a little bit faster. So you have the host operating system. And then Docker is a server which builds and manages containers. okay, app B and the app B's related dependent binaries and so on. That's in a box like this. Now on the right side, you see how a VM works. So VM works through a hypervisor. So there could be multiple VMs, and each VM will have its own operating system, the whole operating system with its own kernel, okay, which is in addition to the kernel that's running the host system. Okay, let's now actually get hands-on. Any questions up to this point? No questions? Okay, so let's okay, let's move forward. So download. So you can install Docker Desktop. I have already installed it, so I'm not going to repeat those steps. I think you will have to create a free account with them. The account is for Docker Hub, which is the registry, so that you can actually post. It's less like GitHub. So just like on GitHub, you can have public repositories of your code. On Docker Hub, you can have public repositories of your images. Okay, so let me. So we have a. Oops, we don't need this. Don't need this, but yeah, you can get Docker from just searching for Docker and downloading the Docker for desktop. Yeah. So we have a certain Docker version installed. Good. So okay. So maybe we should run a simplest. I think this is something that you'll see in the getting started for Docker. So just like any programming language you try, you start with the hello world. So if I do Docker run hello world, so it doesn't find the image locally. So it's gonna pull the library, pull it from Docker Hub, and it pulled that image and it ran. So it created a container and it ran the container. Okay, so here it says downloaded the image and then it ran the container, and that's what it shows here, that this message shows that your installation appears to work and what steps it took. Okay, it pulled the container, sorry, it pulled the image from Docker Hub, and then the Docker daemon, as I said, the server created a new container from that image, which runs, and that container runs a program, and the program produces this output. So this output here, hello, is from that program, and then I don't think the container was deleted. So if you type Docker ps -a is just what the, as I said, containers are just processes. So you can see that this is the container. It already exited some time ago because I ran it. So I can just delete this. So there are no more containers. So okay, so that was hello world. You guys should try it. So let's now focus on our objective, which is to get a model in a container and be able to query it for some predictions, right? So actually I'm not in, I don't know if, I'm already in a Jupyter environment. I don't know if this makes sense, but yeah. So anyway, we don't need Conda at the moment, so it's fine. Okay, what's the list of images we have? So there are a few commands that I'm going to run now. It's just and the references are there in the notes for you to try it out later. So Docker images will tell me what are the current images that I have. So I only have one image. As I said, it's a read-only template for creating a container. It's called Hello World. Okay. So that's the only one I have, and I just deleted the container that terminated, which is the hello world based container. So let's actually make a Docker container for our weather service, okay, for the weather service app. So I think which directory am I in? Okay, so I'm on desktop. So let me just create a weather service container. For that, to create to create that container, I first need to create an image. To create an image, I need a bunch of files. Okay, so I'm gonna first create a directory with some files. So let me very quickly do that. So okay, so I just created a folder called Docker Weather Service. Okay, it's just a folder. Let me go into the folder. And what it has is two files, and those two files are actually just copies from the our nodes. Okay, section 2. So in section 2, you can see that there's two files essentially. It's something called a Docker file without an extension. So don't put .text or .markdown or something like that. And there's another file, which is the file which we were using before. So it's just weather. It's called weather.py. So we had used this Flask. It's just a Flask file from before. Okay, from in fact lecture 1. So you import Flask, and this particular service needs two additional libraries or two additional modules, GeoPy and requests. And given that, whenever you ask for a weather of a city, for example, city of Chicago, first it finds the lat long. Okay, sorry. It first finds the lat long. So here, location, you geocode using the geolocator object, which you get from the GeoPy package. First you get the lat long, and then you do two request queries. One, the first query gets you the grid within which you want the forecast, and the second query gets you the forecast within that grid. And then you just give that response back to the person who queried. Okay, so that's the app, and this was done before. So that's the app. Okay, so now we can just run a build command. So let's look at Docker file for a second. So the Docker file has about 10 lines. So what is going on? So it's so let's look at the first line. It's saying from Debian buster -slim. So this is just the reference for the starting point. Okay, the starting point is going to be some other image, and in this case, I'm just choosing Debian image with a certain tag. Okay, it's buster -slim. So it doesn't matter. So all I'm saying is there's some starting image, and this image is not with us. So it will hopefully be on the Docker Hub. Okay, and we can check that actually. Hub Debian. Okay, let's just search for Debian. So the Debian. Okay. So a lot of people have downloaded this image, but you can just do Docker pull Debian if you want to get the Debian image. But I don't want the Debian image. I want a specific image called, I guess, buster-slim. Yeah, this one. Okay, so that's the reference for why you can use anything here. You can use Ubuntu something. You can search for Ubuntu and appropriate starting image, and then you can give your name if you want in the maintainer. And then what am I doing? I'm just installing Python. In this case, I'm not installing Conda because I don't need that complexity. I'm just installing on the system using apt-get. Okay, apt-get is a package manager for Debian-based systems, including Ubuntu. So I'm just doing an apt-get install of Python in this line, and then going to some other directory and just linking the Python to Python. Okay, so this is not very critical. Now, the most important thing for us is to install the required libraries. So install Flask, GeoPy, and Request. Those are the three libraries, three modules that I need to run my weather app, right? Weather uh, Python file. So that's it. So and the Docker file is also saying that the entry point for this container is going to be Python 3 weather.py. Okay. So entry point is like the starting point. So once you run the container, this is what is going to be run. So, but how do we get to the container? First, we need to create an image. Okay, so we're going to create an image by running the following command. So Docker image build, and the name of the image is weather service, and from the current directory. Okay, the current directory has to have that particular file, which is Docker file, which is what it's reading. And now what it's doing is pulling from Debian. Okay, so it's actually downloading from Docker Hub the Debian image, and then it lists the steps nicely. So it ran the maintainer step. It's really nothing going on, and then it's running apt-get update with all these Python related aspects, including pip install. So it's going to do it slowly. In the meantime, if you have any questions, just post it on Slack. That's going to take some time at least. So it's like, so the Docker file is specifying what packages are needed when you build your new image, which is weather service. And from that image, when I create a container, that container will have those packages so that it doesn't have to depend on whether your system has Python or your system has a GeoPy or request library and so on. Okay, it doesn't matter as long as your system has Docker so that you can run the container. Wow, I think I went for an overkill here. We did not. I don't think we need GCC and all that. Actually, there are some really small containers, really small starting images that you could use. I just happened to choose this Debian image, and you'll see how big that image is pretty soon. So let's actually go here. In the meantime, I don't think we need Google today. Yeah, so maybe I should create another terminal. It's still installing. Finally, it got to setting up Python, Python 3. So in the meantime, okay, it looks like, oh, now it's installing the packages we actually need, Flask, GeoPy, and all the dependencies. That's good. So do you have any questions in the meantime? Okay, anyway, the build process completed. So now let's look at what happened. So we were trying to create an image. So hopefully Docker images should tell me that there are images created. Okay, first thing you'll see is that the Debian image, which is downloaded, uh, is is there, and so which is there, so which we got from the Docker Hub. And the next is the image that we created. It's 500 MB in size, so pretty bulky. That's because we did an apt-get update and installed Python. It should not take so much space, so maybe there's ways to trim it. So anyway, we got the container. Okay, so we got the image by the service. Now we can actually run the service, and we're going to run it. Run this, so we can use this image to start a container. Okay, we're going to start a container in what we call as a daemon mode, which means that it will run as a server. Okay, so we will not have an interface to it. So here's the command for that. So run -d means that it's in the daemon mode, and the next command is to port forward. Because if you look at weather.py, it's actually the app. I did not give a port, so the Flask app is going to run at 5,000 inside the container. I'm just forwarding it back to 5,000. Okay, and starting point is this image weather service. This question. So Docker images are just used for creating Docker containers. Yes. So they are primarily used to just create Docker containers, in the sense that containers are what's disposable. What's actually important is the image. It's like the snapshot. Okay, and images are what you pass around, what you store as on repositories. Okay, so containers are just just running perishable objects in some sense. So I ran this command, and it gave me some huge string, which is just the ID for the container. So let's actually look at Docker ps -a is not needed, but -a just means all. So you can see what's the container, what is the image it's based out of, what was the command that was ran, and when was it created, and what is its status. Okay, if it's exited or it's still running, and what are the ports being forwarded. Okay, and some I think it also has a name, a container name, instead of just using this string here. So since the container is running, we can actually so weather.py. So this doesn't need JSON object or anything. So let's actually, should I use Postman? Okay, let's use Postman. So let's change the location to localhost 5,000. And it's not a post, but a get. And there is no such thing like this. None. Params. Key is going to be, I used message as a key, and value is going to be Chicago, let's say. And let's try to send it. Okay, so we got a huge JSON response, and this is what is expected. I mean, you can parse the JSON object, but we're not going to do that here. It's telling you inside properties what's the forecast, like rain likely in this period, I think for tonight. And similarly, you'll get a forecast for tomorrow morning, and so on. Okay, so we got it. So we ran a container in the daemon mode, and just because of port forwarding, you can just do localhost 5,000, and we were able to query. Okay, so we did something, right? We were able to encapsulate our weather service into a container by first creating an image from a base image, in this case Debian, and then from that image we were able to instantiate a container, run it in daemon mode, and it keeps running, and you can access it from local storage. So sorry, from the local host. So you could have run this whole thing on AWS, on EC2, right? EC2 is just yet another terminal for us. We know how to run Jupyter from there, as well as terminals from there. So we can run a similar service from there. So if you run it on EC2, you can actually publicly expose the URL. So you will get a public IP address. So as long as you do the right port forwarding, then you can actually query from a public URL to the weather service. But it's just that the weather service is running within a container, which is running within the EC2 instance, which itself is a virtual machine, and it's interacting with the outside world and predicting, is producing information, right? It's, in this case, it's a weather service app that's telling you the weather. So, so that's good. So now we'll move on to orchestration. So what is orchestration? So let me jump to that. Actually, yeah, so we pretty much finished what we did here. So we just showed weather service, but you can actually, we'll try to create a container for our model in the next slide. In fact, PyTorch models. The PyTorch model you'll see that the container is going to be, not the container, the image is going to be pretty huge. Maybe I'll start it and then discuss the details. But you'll see that if you just dump it on EC2, for example, to serve models, what you get is portability clearly, because from the image, you created a container, and it doesn't matter whether the environment happened to be an Ubuntu virtual machine or Ubuntu EC2 instance, or a CentOS EC2 instance, or even a Windows EC2 instance. It doesn't matter. Okay, as long as Docker is present on that side. But it doesn't itself give us any additional features, such as what if the container stops working for some reason, okay? And scalability, it's a single container on a single compute instance. So can we manage scalability and those types of aspects? And that's where orchestration comes in. And we're going to look at ECS today, which stands for Elastic Container Service. Okay, so there is going to be two parts. The first part is going to be ECR. So there are a lot of acronyms in this line of work, I guess. So ECR stands for Elastic Container Registry. So this is essentially plays the same role as your Docker Hub. So Docker Hub is a container registry, so it's an image registry where a lot of different organizations like Python, Debian, Anaconda, Continuum OS, Continuum IO people, or anybody can put their images, okay, share their images for other people to use. Similarly, ECR is a container registry which is internal to your organization. Okay, so for example, internal to my account. So I can dump images to ECR so that those images can be read from, let's say, from my EC2 instance, and I can, create a container from the image which is present in my local private ECR container registry, essentially. Okay, so let me come back to orchestration, but before that, let me actually jump a few steps and create the model prediction Docker image, because it's going to take some time, and we know exactly how to do it. So basically, there are going to be, again, two files, a Docker file. Okay, this is exactly very similar to the previous Docker file, but it'll have two additional things, artifacts, which is the trained model, PyTorch model in this case, a neural network model actually, and the movies metadata. Okay, so we're gonna have these two files and the Docker file in the same directory, and we'll have a Flask app, right? So the Flask app code is here. It's a little bit long because we are redefining what the model was. The model is a neural network based model. So we have to, when we read the model from disk, we also need the neural network structure where the numbers will fit in, right? So, so that's why it's a little bit longer. Okay, so let's actually first start creating an image based on this model prediction. And then we'll get to discussing orchestration so that it does parallelly. One thing I would less notice, I'm starting with a Miniconda based image, because Miniconda image we already know how to install. So we can install Torch very easily, PyTorch very easily over there. Okay, you can also start with PyTorch itself. The PyTorch organization itself also has images. We can use them. So it really, it's just a question of choice from which image you start. Okay, and so of course you start from an Ubuntu image, then you have to figure out how to install for example, Conda from scratch or Python from scratch, and then install PyTorch. Okay. So with that said, let me just create the directory. Okay, so let me go to, or I can do it here. So the service is still running to, so that you can check by again typing the service, what I created earlier is still running. I can kill it, but maybe I'll kill it later. So I just created a folder called Docker Prediction Service, which has exactly those Docker files. So those 4 files: a Docker file, the movie metadata file, which we have been using so many times throughout this course. Now this model was trained in lecture 1 essentially, so you guys should also train it. If you try to use Google Colab if you can, and then recommend.py is the Flask app. Okay, so. So if you want to double check the, if the Flask app works, then you can just type Python recommend. So if I have Flask locally, then it should work. So I don't have Torch, PyTorch locally. Sorry. So that's fine. So okay. So we have this. So let's create a prediction service. From the current folder. Remember, current folder, when running this command essentially creates an image from this Docker file. And we saw what the Docker file content was. It's going to download the image called Continuum Minikunda latest. And it may be a big image. From there, it's going to ultimately create me a prediction service local image. Okay. So let it do that. And let's go back to orchestration. Okay. So there are many orchestration solutions. As I was saying, one of them is ECS by AWS and Kubernetes, which some of you might have heard of. And that's actually an open source platform. So you can do a local hosting, as in you can do a self-hosted version or a managed version by GCP or by even AWS. Okay. So why should data science folks or business analyst folks know orchestration on top of containers, right? It's the same idea. For example, knowing serverless lets you just focus on your model and a wrapper, simple app around it. We're using Flask, but you can also use something else, and then not worry about deployment, right? So at the same level, ECR and ECS is mostly about once you create a model and if you want to share your images to the rest of the organization or get certain DevOps features, like once you containerize your thing, your model service, then you get fault tolerance and scalability and so on by doing orchestration. So, but of course, there's a con, which is that there's a non-trivial setup cost and complexity, especially learning these things, right? There could be so many things that we're navigating through some complex pieces of software. So reading documentation is a cost, as cost of time as well. But it's worth knowing these things, at least be familiar with them. So what we're going to do next is to deploy our model. So the Docker image that we're creating parallelly, right? It may be going on here, not here, sorry. Here it's still working. So let it continue to work. Once it creates the image, we're going to deploy it to the container registry. And then we're going to use Elastic Container Service by AWS to deploy the container based on that image. Okay. And finally, we're going to set up a load balancer. So we'll not do this actually today. Load balancer part is not very critical, but what a load balancer does is mediates the request, the HTTP request coming in, and to the container that eventually reads, gets the request and responds with predictions. Okay, so load balancing, I think we can maybe skip it. So let's look at container registry. Okay, so we essentially want to send the image to a model registry, and that's registry. You can certainly publicly, you can send it to Docker Hub as well, but instead we're going to send it to Elastic Container Registry, and we need, um, and so basically we are doing that because ECR allows better integration with the rest of the AWS platforms, in particular ECS. Okay, so ECS, for ECS, we can always read an image from Docker Hub as well, but we will try to read the image from ECR. Okay. So we are creating a Docker image locally, as in the other tab. We'll push it to ECR repository that we'll create. So let's go to the ECR link. So we have a lot of AWS tabs open. So let's see. So we don't really need this. I don't know if were people able to play with this deployed recommend serverless prediction service. I don't know. Did anybody try? The URL is in the general in the chat box. But in the meantime, let me go to ECR. Okay, it's over here towards the bottom right. So let me click on that. And so you can create a repository, let it load. Wow, it's taking some time. So let's see, did we finish the container? No, still working. But you can see now it's installing PyTorch, which was the essential ingredient for us. Let's actually put this. Okay, so ECR is here. So you can see I've already created a repository before, but let's just go through the process once more. So create repository, temp recommendations. For now, we don't need this or the image scan and all that stuff. So just give a name and create a repository. So once we create a repository, what we need to do is actually visible here. So temp repository is something I just created. Now, if you look at the top right, you click on the view push commands. It tells you exactly how to push your Docker image. For example, we're currently doing this. Okay, we're building a image, right? So that we are doing step 2. But the step 1 is what we need to do is to give access to Docker to be able to push. So give access to Docker so that Docker can push the local image to our ECR, okay, our repository. So that you can just literally copy paste from here and paste it into your command line, which I can do right now. Oh, okay, I should have kept the other terminal. Okay, I just ran this command and access denied because I'm not authorized to perform. So remember that the user was just was just an S3 user. They were not. They were only allowed to manipulate or work with S3. So that's why my access was denied. So let's actually fix that. So let's go back to S3 and fix that. So services S3. Oh no, services IAM. So we just created the user earlier in the session. I think it was called S3 user. So what we're going to do is add permissions and attach existing policy, and then we'll see there's something to do with ECR. Nope, that's not the one. Let's see. Oh, Amazon EC2. Okay, this is the name of the permissions. Okay, so Amazon EC2 container registry full access. Okay, let's give this additional permission for now. Oh, by the way, after this exercise, we can we can delete this user for security reasons if needed. Okay, so we added this additional permission, add permissions. And so now this person is, this particular programmatic user has two things that they can access and work with. Okay, this is too much of access, by the way. You should generally give the least amount of access needed to get the work done. So now let's go back here and run the same command. So what this command does is give Docker access, and you will see a command succeeded, therefore Docker can log in, okay? And so that's good. So now we have access. So now let's actually go back to services and ECR. Temp recommendations and view push commands. So we just executed this, okay? It just gives Docker access. We were actually doing this. I don't know if it finished. Oh yeah, it finished, thankfully. So now an image has been created, so we can see that by typing Docker images. So there's a service called prediction service. Okay, so there's this image called prediction service. From this image, we can run a Docker container locally and get a sense whether it's working or not. So you can see that in the yeah. So in my so this was exactly what we just did. This was the app, the Flask app. So you can see that I've changed the port to 80. Okay, and this was one of the exercises from the previous lecture. So if you haven't done this, all you have to do is change this port. So we just ran. So this was a Docker file, Docker file, and we just built. We just ran this command. Okay, so now this is incorrect actually. So we can run it using a different command, which is Docker run. So Docker run -p. So let's go from 80 to 80, and then prediction service. Okay. It's called prediction service. Yes. So now it's running locally on my machine. So this is just to test that it is working. So if I click on it, it's not successful. Oh, it says a prediction service. So I actually have to do Postman to get there. So let's actually go to Postman. I only have 8 minutes. Great. Okay. On Postman, I think. So let's do this. So we don't need any. So it's not get request. It's actually a post request. Let's go to body, raw, JSON, and give a JSON object UID something 20, and method is not allowed. Okay. Is this not the oh wow. So I don't think this is the, okay, let's try this. Okay, this is actually a GET request. I didn't check this. Okay, so it's not really post. So it's just, locally, if I just do a GET request with UID something, then I'm getting the list here, which is some movie ID and the movie name and some score, and movie ID, movie name, and some score. So this is using the PyTorch model. So it's really, it's working. So next, and you can actually see the debug logs here. So the post request was not allowed, but GET requests are fine. So anyway, so we didn't need Postman there. Let me just go back to. Yeah, sorry, I think I did not share the screen when I was discussing this, but what I was trying to show was that you got this. So I ran the service run, right? And then initially for the first time, it has to download some data. And then it started running the Flask app. And I had done a couple of post requests from Postman that did not work. It's supposed to be a GET request, and you can see the GET request. I don't know, 0.0 80 question mark UID, let's say 20. Okay, I just the service is not running, so let me start the service. Because it was not in daemon mode and I do the control C, it stopped. So we got some predictions. Okay, this is on the local machine. So what we did is create the PyTorch based image, run the container using this very simple command, docker run from this container, and do the port forwarding from the container port to the port that we can access from our host machine, in this case, the local machine. Now, what we can do, and maybe I'll again touch upon this. Actually, maybe let me do it next time. Is just a very simple operation is to push this image to the ECR and then just do some simple setup on Elastic Container Service to run the same container. And then you guys can access that through a public URL and do the same query. So I'm using the recommendation system, so the recommendation prediction model again and again. But that's what we're going to do towards the beginning of next lecture. So any questions at this point? That was seems like a lot of work. Um, okay, if there are no questions, for now, let me stop the recording.